I'd like to thank you all for joining and taking the time out of your busy schedules to learn a little bit more about HeadSpin and the topics that we're going to address today around real-time communication testing. My name is Nadav Gordon. I'm responsible for strategic accounts here at HeadSpin. I'm based in New York City. I'm joined by my colleague, David Broker. He's one of our senior sales engineers. And so today we'll be talking a little bit about how your organization can use the HeadSpin platform to run tests on your applications across a variety of different use cases in real-time communication situations. And here's a look at the topics that we'll be covering today. So I'll spend a few minutes giving you a quick overview of HeadSpin as a company and a platform, and then I'll turn it over to David, who will walk you through a few real-time communication scenarios and a corresponding demo, and then we'll follow that up with a Q&A session at the end. So if you have any questions, you can submit them by clicking on the Q&A button at the bottom in the control panel of the Zoom application, and we'll answer them after David concludes his demo. So I'm now going to turn off my camera here to conserve some bandwidth, and let's get started. So who is HeadSpin and what do we offer? So HeadSpin is a 7-year-old company based in Sunnyvale, California, and we were founded on the premise of helping our customers execute synthetic testing on real-world digital experiences. So as you may be aware, speed, ease of use, and ensuring the experience is consistent are critically important to the success of every enterprise. And that's where HeadSpin's platform really comes into play. So we recognize that delivering a great digital experience is an act of deep collaboration between product management, development, testing, and site reliability engineering teams. David, I think the slides are skipping. You might want to go back a couple there. And so our platform helps to drive that collaboration. And we're backed by Google Ventures and other notable firms. And in addition to Google also being one of our top customers, we've been blessed to be able to partner with some amazing brands such as Amazon, Meta, and others whose digital experiences are undeniably tied to business results. And we service customers across industry verticals, and some of these customers are being served across multiple geographies with hundreds of devices under test. And so our platform allows organizations to get a clear end-to-end view of the digital experiences they offer. And the way we're able to do this is by using real devices and quality of experience analytics for mobile, web, audio, video, and other connected experiences. And so as you can see here, our platform can be broken down into 4 pillars. The first on the left is our global device infrastructure, through which you'll be able to access hundreds of real devices to test and monitor your customer experiences end-to-end on actual carrier and Wi-Fi networks. We currently have a presence in over 50 countries and 100 different locations globally. The second pillar is where you have test automation and support for essentially all testing frameworks. So we have native integrations with Appium and Selenium, and allowing for seamless integration into your CI/CD workflows, and enabling functional and performance testing for both pre as well as post-release. And our open APIs give you the ability to export data and insights to any BI and data visualization platforms, as well as monitoring dashboards. The third pillar is where you'll find performance and quality of experience measurement and machine learning. So our platform allows you to identify bottlenecks and issues by surfacing the underlying root causes from all layers of your technology stack. So whether it be audio or video quality of experience to the code and even packet visibility, our platform gives you the ability to measure KPIs that you care about, whether they are extensive app, device, network, and even critical user journeys and screen transitions. We currently have 140 KPIs that come out of box in our platform today, and we can additionally customize any other KPIs that your organization cares about and wants to measure if they'd like us to do so. And then finally, on the right, you have insights to actions. So this is where HeadSpin really separates itself from other device farms where you typically only get a pass or a fail grade on your tests. We're able to deliver deep regression and aggregation insights throughout the digital lifecycle. So over time, you can build your regression intelligence using real analysis and metadata from the sessions that you run on the devices that you choose to run them on. Next slide. And the final piece here is how we deploy. So I mentioned earlier that we have infrastructure in 50 different countries and 100 different locations, and we offer several different models, including on-premise, cloud, hybrid options, or create your own lab capabilities from a deployment perspective. So if you're looking for an on-premise deployment and you want to host your own devices internally, we have appliances called the P box and the AV box, which you can see here on the left-hand side, and you can host up to 24 devices in a P box and 2 devices in an AV box. The AV box in specificity was built for rich audio and media use cases and is also used for others that we'll get into in the latter part of the session. It's isolated from sound and light, and it's the only apparatus of its kind available in the marketplace today. The second option is cloud deployment, which is our most popular. And in this model, you would leverage HeadSpin infrastructure by picking a data center in any one of our 100 locations globally and deploying the devices of your choice. Thirdly, we offer a hybrid model where you essentially get a best of both worlds approach and leverage, you can essentially leverage a mixture of HeadSpin infrastructure as well as your own. And you have the ability to even deploy a P box in a country where we don't have a data center if you choose to do so through one of our partners. And lastly, we offer a capability called Create Your Own Lab, where you can plug in devices to your laptop and run tests remotely while leveraging the HeadSpin remote control that David will show you as part of the demo. So now I'll turn it over to David to walk through a few of the scenarios that we were talking about from a real-time communication perspective. David, over to you.
Yeah, thanks, Nadav. And as you mentioned, I'm David Broker. I'm a senior solutions engineer at HeadSpin. And so we have a few examples I want to show, and then a demo of one of the particular use cases. And as he mentioned, we'll follow it up with some Q&A. So here's kind of my flow for what I want to cover. I mentioned I want to walk through some use cases, how to manually interact with the devices on the HeadSpin platform, how to do some automation against these devices in real-time communication situations, and a few customer examples. So the real-time communication use cases I want to walk through are phone calls, SMS and MMS messaging, one-time password use cases, as well as messaging apps like WhatsApp, DMs, or anything else that you on the phone need to communicate with another person, so like a third-party application. And the last thing I want to kind of touch on is web conferencing applications. For example, Zoom, like we're all using, or Google Meets, or something that is similar to that. So the first thing I want to show, and I'll demo this as well, is a phone call between 2 devices. So there's a lot of different factors that play into this particular use case, but it's something very important for a lot of our telecommunication customers. But you could also see the same approach in different messaging or direct messaging apps, like Facebook's or Meta's messaging application. You can do a very similar use case with calling, and that's something that they'd want to validate that works correctly, just as an example. But we also use this use case for a lot of telecommunication customers that we interact with as customers. And so there's kind of 3 layers of what's all going on here. So one is the fact that these are real devices. So you can test on an actual device that a consumer would have in that telco company. The second part is these are real SIMs. So we're not faking any of that sort of SIM. We're actually testing the physical SIMs that those customers would be testing on. So in this example, this is a Roger Wireless SIM card we have, and that these are running on that Roger SIM, so that'll really capture exactly what a consumer of that company would see on their phone line. And the last part of that is cool. You can show that the phone goes through, but how can we tell if we can put audio from one to the other? How can we hear that on the other end? What does that sound like? And how close does that match up to the audio that we want to send over? And how can we send audio in an automated way? We'll go into all those sort of details as well, but that's just something to be thinking about in this sort of environment that has a lot of different variables to come into play. The next is an SMS example. A lot of similarities between the phone call, with the exception of that audio use case, but you still want to validate that you're able to send cross-platform SMS, MMS messages, and that they're received as they should be by the end user. And additionally, that's something that you'd want to test on real SIMs. You wouldn't want to fake that. You'd want to make sure that that SIM can message on that network and it comes across appropriately. Same thing with pictures. You want to make sure that the picture can be sent and received from other users. And so these are just some examples of those same phones that are calling, texting, and sending messages to validate that you can send those pictures across the network and that they can be received appropriately. Now, one-time password is something that's a little different than those first couple use cases. This is more from a consumer that wants to sign up for a website or validate that the user is who they say they are. And this is something that is very critical and it can be time sensitive. These can time out in the matter of minutes to hours, depending on what that website or the customer wants it to be set at. So that password being sent and interacted with in a timely manner is critical. So if there's any sort of latency between that being sent and received and used, it could be detrimental to their testing environment. And that's why real-time communication and using real SIMs is very, very important to us. And you can see in this instance that there's a login pin that was sent over to this device so that they could appropriately interact with whatever application that they're trying to use, just to show you that it works just as those texting examples works as well. And the last example is web conferencing apps, right? So this is something that we can see, we can listen, send audio in this web conferencing app. I use Zoom as an example as because we're using it today. And the other important part of this is there's also a chat aspect of Zoom that you'd probably want to validate as well. And lastly, it made us be, a lot of those were peer-to-peer, but these can be multi-tenant, right? You can have 5 different people on the same Zoom app or whatever that application requires. And so that can be kind of hard to test with just a handful of devices that people have in their hand. And that's where having this remotely and able to be accessed and automated is really critical to be able to show those user journeys for our customers. And I mentioned this before, and kind of on most of those use cases, but specifically on the phone call use case, is this concept of audio injection and audio match. So within the platform, you're able to inject audio files to the device. And you can also do this manually, and I'll show kind of both ways to do that. And so if there's a specific audio file that you want to submit from one phone to another, you can use an API, and then that phone will then go ahead and prepare that and then send it across. And then you can listen on the receiver end to validate A, there was audio, and B, the correct message was heard. And how we want to validate the correct message was heard, besides logging into every single test case, is we can do what we call an audio match. And that'll show how good of a match score it was from a wave to wave comparison from what it should have sent into what was actually received. And with that, you can also see if there was any great degradation in that or how close that match score was to the intended file that you meant to send. So now I'll show some manual usage and some automated usage in a demo. There's a few things I want to kind of highlight on the manual usage that I'll make sure to show throughout this. So the big thing is like you can use many devices simultaneously, but it's really simplistic to use 2 devices simultaneously on the HeadSpin platform. You could probably see that and assume that from those images, but you can actually hold these phones side by side in the platform. And that makes this sort of use case a lot more intuitive and easy to use for our customers. And additionally, as I kind of mentioned, there's an ability to kind of live stream the audio that comes across, as well as live stream audio to go into the phones. And that's really important for our use cases as well, because there's sometimes that customers want to validate that the audio is actually appropriately there. Or for a manual user, it doesn't really matter if you can do this image injection afterwards. They just want to hear it live and validate that it's there, as well as talk to the device and send their own audio to the other devices. You can still use audio injection for manual use case. There's still a lot of validity to that in the example of using the audio match, but I just want to highlight that both are available to you. And then for the automation, I'll show kind of the script that I'm using to control this. And so how we can sort of use the phone from an automated standpoint, we're going to use Appium. We're going to use the Appium library from Python. And we're going to show how we kind of interact with the phone, how we're able to send a call, receive a call, and then additionally sort of the more HeadSpin specific APIs for the actual injection that we're running, as well as the audio match, because all those are APIs and they can be put inside of that Appium script. So let's go ahead and show this live. So here I have the HeadSpin environment. I'm going to use these 2 phones. So these are both sitting in Canada, and they're an iPhone and an Android, and they have audio. We can see that from this little indication here. So we should be able to hear the phone call going through, as well as talking and receiving on the phone call. And something I wanted to highlight here before we jump in is we can see just from a glance, and this is a demo environment of the more geographically rich regions we have just from this small screenshot. But if we scroll through, we can see a bunch of different devices and a lot of different geos that we have available. Just something I wanted to highlight since I was already in the platform. So to actually go ahead and use the device, you can find the device that you want to interact with. And I mentioned I want to interact with this Samsung and this iPhone. You can hit the start button and that'll start to bring up the device in the screen. And, I only selected one, so it's only going to show me the one device. However, what I also could do at this point is go back using this devices menu, and I could find this iPhone device that I want to use and start that as well. And then we have this concept of the device tray. So these are all the devices that you have that you're using or you've used in the past that kind of cache for you. And what you can do with that is you can select, I want to see this device on the right side of the screen here. And then that'll bring up that device screen. So you can interact with both of these at the same time. So for the calling example, what I can do is I can find this iOS's phone number here. I can copy paste it from the UI and I can go ahead and I can start a call here. And then we'll initiate that call from the Android side. And we can see that it's using this board, which is how we're able to hear audio. If I play this, we should be able to hear the ringtone. I'm not sure if that'll go through the Zoom application or not. And then we can accept the phone call and we can actually talk back and forth. So the other aspect that I kind of alluded to is there's a concept of being able to use live audio from a user. So there's a microphone and a speaker here. And so what I could do on one of the selected devices is I could initiate the microphone. And then if I start talking to it, you can see my waveforms are being picked up by this microphone that's indicating that, okay, the platform is hearing me. And then what I could do on the other end, it'd be a little kind of annoying since I can hear myself again, but I could hear it on the other phone as well. And so you can see that happening live. The last thing that I wanted to show, regardless of whether you are listening to the audio live or whether you're talking to the device, we can also record sessions and that'll capture everything that's going on the phone. There's also some other webinars that kind of go into more detail of what's all produced in this, what we call performance session, that gets produced from recording these sessions. And I'll show a quick example of that. So just kind of hold that in the back of your mind for now. But what I wanted to mention is regardless of whether you're listening to it live, the audio will still be captured within that performance session. And as I mentioned, I will show an example of what that looks like here at the end. In the meantime, I'm going to go ahead and end the phone call. And any of those other use cases, like the texting use case, would be very simplistic to do. You just grab the messenger and you can start texting between devices. Or if it was a Zoom application, you could open up Zoom on one of the phones and start a conversation that way through that application. So the other thing I wanted to show was through automation, how this is done. So I'm going to use those two phones again. I'm going to use this script here, and I'll show kind of more details about that script, but I'll go ahead and kick that off with a Python call. And if you're familiar with Appium, this is strictly Appium capabilities that are found in the platform. They are found by finding the device you want to interact with, and you can find the automation configuration and how to connect to the device. And then from there, some Appium knowledge will be necessary to select the right package and activity. And from there, we just use Appium commands to open the call menu, dial the number, receive the phone call, and initiate that exact phone call in real time. Just want to check on, okay. And then the other thing that I was mentioning is the audio injection. So I put everything inside of a different library. So what we need to do is prepare the audio as well as inject the audio. And so I abstracted it out. But what that looks like in the actual script itself is something like this. So there's a prepare audio call. It's a post request that uses the WAV file that you've supplied to the HeadSpin platform. And then there's the inject audio, which uses the same WAV file to then inject on the specific device you mentioned within the script. So you can see the device address, and that'll inject the audio from one device to the other. You can see the script is still going through. But what I would also like to show while that's working is what the end result would look like. And this is where I was mentioning performance sessions. I mentioned we'd come back to them. So I want to do that very quickly. So we can see a recording of the entire test. So we can see on this iOS device, and in this instance, this is the receiver device. So this is the one that received the phone call from the Android and received the audio injection from the Android. We can see the call was answered and then it was hung up. And then actually here's a bunch of KPIs that we capture. As I mentioned, there is another webinar to go into more depth about the performance sessions themselves, but we can also see that the audio match was here and that the audio match was a 99% score. So it's very close between what was actually heard on the phone to what we injected over. And so that means that the audio was correctly added. And the other thing to highlight from an audio KPI standpoint is we do have KPIs that show the loudness. And so what that can tell you sort of from a high level in different applications, but specifically on this one, is if the audio was actually there. So we can see here's where the phone was ringing, and then here's where the message was sent over from one device to the other. And additionally, I mentioned that the audio will be captured within the performance session. And so if we played this video outright, we could hear the phone call. And then when it gets to the injection standpoint, we could hear the injection from one phone to the other. It's a little quiet because of the wave file I chose. It looks like the script ran in the background before I showed it. The completions are just saying that the audio was injected completely and the device was able to send over. I could try to run it again and we could watch it occur. And also I am having performance sessions. So this is the one that just occurred 3 minutes ago, and we can see this one is spinning up now. And so we can see that the iPhone has been collected and it's starting the session, starting that recording session. Something to note as well is I only recorded the iOS device. I did not actually record the Android device. You can, however, there was nothing from the Android device that was really interesting to inspect. So I just chose not to because the audio is being injected from it. There's nothing that the Android device is listening to in this particular use case. And when this is kicking off, this is taking a little bit longer to start this session, which is kind of our roadblock here. I will go ahead because it did go through last time, but it seems like it's taking a little more time. There we go. We have the recording started. So then we should be grabbing the Android device, and it looks like we did. And as I mentioned, this one is not being recorded, so this should start pretty quickly. So we can see that it's injecting the phone number. It's calling the other device. The device should answer. It did answer. And then we could listen in and hear it, but it's going to be captured in the performance session anyway. From the script standpoint, we can see that it prepared and injected the audio. So if we listen right now, we should be able to hear the audio that we're injecting. And then it'll go ahead and end the phone call after it's completed the audio file. And we can see that happened. And now both devices are ended the call and they'll be released shortly. So that concludes the overarching demo. I just mostly wanted to highlight that one use case. Oops, sorry about that. So the summary of value that we want to drive and make sure that's kind of understood from this demo standpoint is we're testing on real sim devices. None of this is really mocked. You can get into a lot of unique use case testing, like the OTP password. That's still going to be, or the OTP, that's still going to be available in something of this nature. We can run the audio and quality validation. We didn't touch too much on the video because that was kind of not the concept of this webinar. However, you were able to see the audio portion of that being done. And additionally, the other thing that's awesome, that's great about this platform is you can test on the prod applications of, for example, Zoom, like we mentioned, but also you can test on the non-prod applications if they're available for you as well. and the last part that's sort of touching on the OTP specifically is you can ensure timely and accurate messages are being delivered. So now we'll open up to the Q&A. I see that there's already some questions coming in from that.
Yeah, thank you, David. Nice demo, appreciate it. So we have a bunch of them here. We'll start from the top. So we've got an anonymous question that is asking, how can we ensure that the one-time password that is sent is the same that was received?
Yeah, so a lot of the customers that we interact with, they'll have a way to find from the server side some sort of identifier that links the message that was sent to the message that was received on the phone. So a lot of times it's not something like UID, but some sort of unique identifier that ties the two. And then with like an Appium script, you could kind of parse out the message that was actually sent on the phone and compare it to what the server sent over and make sure that they actually are the same. We have seen a lot of instances, and this is something that the tool has actually solved for some of our customers, where the formatting is wrong in certain geos, and they can compare it with that server side and validate that, oh, there is actually a problem with this geo or with this device type, and we need to take a look at this. But that's how you do that. So you'd perform some sort of assertion within your Python script and then fail the test accordingly.
Okay, thanks, David. And thank you for that question. The next question comes from Francois. And so he's asking, how do you align audio match under various network conditions, such as delay or packet loss?
So I was mentioning how we have the real sims, and that network is going to be very similar to what you'd experience in real life. We do have ways to modify the network conditions. We call it network shaping. So kind of to your example, we can increase or decrease the bandwidth that the phone is experiencing. We can induce packet loss or round trip time. And so what we would take that approach to do something like that manner is we would run that match score. We could see how good the match score was in baseline good conditions. And with tagging the session, and what I mean by tagging the session, let me show this session that we were looking at before. We can add these tags here. So we could say network and just say maybe poor or something, some sort of generic condition that matches and is similar to one another. And then you can compare like that audio match score within the different conditions. So let's say, for example, in this example, the match score is 99. So that's like 99% match score. Perhaps with a horrible network condition and a lot of lossiness, it drops down to a 60. And so then you can kind of align those two with what the network condition is, as well as what the match score is, and you can see what sort of comparisons there are across that spectrum.
Thanks, David, and thank you for that question, Francois. So the next question that we have is from Arun. So how will audio match confirm quality parameters for noise suppression and echo? Is there any possibility to verify audio quality with and without Zoom audio processing enabled for voice over IP applications?
So as far as the first portion of that, the match score is not indicative of what went wrong, right? It's just more of a one-to-one, how well the waveforms lined up, right? So from that, you'll gather that there was an issue with the audio. From there, how you would actually determine the root cause, whether it's echo or noise, that you could use some sort of other tool like a MOS tool or something of that's kind of outside the platform by stripping the MP3 from the MP4. Additionally, you could hear it manually and see what sort of reason degraded the score, but there should be a lower score when those sort of externalities are put into the audio. But it doesn't exactly tell you what caused it. It just tells you that there was something wrong. Does that make sense? And the audio quality with and without audio process enabled, if I understand your question correctly, basically, there's a way to do voice over IP or voice over, can't remember the other name, within the Zoom application for a mobile phone. And I believe that's just a setting. If this is the correct, use case and assumption, what you could do is you could just disable it. All these devices are real devices. So whatever you can do on a phone in hand, you can do on the phone in here. And so if there was a way to turn off that and then compare the two, assuming that that I made the correct assumptions on what your question's asking, that's how you could handle that. And then you could do something very similar to the last part about different bandwidths. you can do a very similar thing to with and without, and just tag it accordingly and see where the differences lie there.
Okay, thank you for that question, Arun. The next question comes from, and I apologize if I'm mispronouncing your name. It looks like it's Tanaya. Does it diagnose whether the issue is due to network or audio processing on the device itself?
So it doesn't necessarily come out and tell you from the match score or anything else within our list what the problem is. But we do have a bunch of KPIs from the device itself, like CPU usage and memory usage, and including the network capabilities. So in a situation where you're in a poor network scenario, or there's something wrong with the network side, and I don't mean induced by necessarily the tester, I just mean by, you know, the platform, the application itself. You can look at those sort of TCP times and see, is this taking longer than it should, or are those all in good condition? And you can kind of make educated guesses and do a deeper dive on the phone itself. But we do give you a list of KPIs to kind of help triangulate the issue, but our platform is not something that will tell you directly where these issues are coming from.
All right, thank you for that question, Tanaya. The next question is from an anonymous attendee, and it asked, what is the best way to ensure timings of automation between two real-world devices?
Yeah, and that makes a lot of sense, because that's something that definitely can be induced from testing, especially, you know, there's so many variables that come into it. A lot of what I think gives you the best control is running out of one central framework, so you can make sure that the interactions between one device are after another device. For example, if I was making this call from two scripts, there's not a good way to say that the phone call would have been sent before the other device was ready, right? And so I think in that scenario, it's really good to control that from one central framework to ensure that the device, let's say for caller receiver, the receiver is ready to be called by the caller before you actually initiate that call. And so that's where having it in one central location of the controlling of the automation, one central framework, is the best way to make sure that that all is going to line up before you start sending signals back and forth.
Okay, thank you for that question. The next question comes from Nicolas. So he is asking, how is the match score generated? Is it a spectrogram comparison?
So there could be a deeper analysis on this with some, you know, a specific phone call, but what I will say is the way it's done is a waveform comparison, and what it exactly is doing is basically from the reference you give it, there's and I will show here what I mean by that. So you give this range for the time that you expect the audio. So that's this lighter gray portion. And then what we do is we take the audio that we have to match it against, and then we slide that wave back and forth until it has its best fit. And then from there, we tell you the score of where that is. So in this case, we had a really good match, but there are times where the match isn't as good, and it just finds the best fit and then tells you how close those waveform comparisons were. As far as the actual waveform comparison algorithm, I'm not too clear on that, but that's something that we could follow up with in a separate call if that's something that's of interest.
Thank you for that question, Nicholas. Next question is from Francois once again. So do you measure audio quality, i.e. codec distortion, echo, etc., as well as delay impact or conversational on the conversational aspect?
Yeah, so it's kind of a two-parter. So the first part is the audio quality. So we're strictly doing a match comparison, so it could tell you that something's wrong, but as I said before, it won't tell you exactly what the problem is. As I kind of mentioned, you can still take the MP3 off of the MP4 video we provide. And just in case that wasn't clear, because I mentioned that, but I didn't show, you know, the MP4 video is a downloadable part of this tool. And so you could always do that and then do some post-processing and put it in some sort of MOS, audio MOS scoring tool. And so, as I said, we can tell you that something's wrong, but we can't tell you exactly what it is. As far as delays, you know, that's where you could use something like this graph here that gets produced and see if there's any sort of lag or anything between one user and another, and make sure that if there is, you can kind of get an idea of it. So in this instance, before we hang up and it makes that beeping sound, you can see how long it was since we last heard audio until that beeping for the end of the phone call took place. And maybe you were expecting another message in that time, or maybe there was, and you want to see how long between those two times that audio is received. And so you could look at that and see from there, from what you already know about your test, if there was some sort of delay in that regard.
Okay, thank you for that question, Francois. We have another question that came in from Tanaya. So the question is the platform able to test the audio under various conditions and score the quality? Basically see how effective noise suppression is, how good the echo cancellation is, does it generate a MOS score, and do you look for AV sync issues?
Yeah. So, kind of take the last one first. So we don't do anything with AV sync. It's something that we've looked into at different periods of time, but it's not something that we feel comfortable to be able to handle. There are a few ways that we could do based on known quantities of when audio should appear. We could get something close, but it's not something that I don't think we would feel comfortable promising. But I think it's something that we could look into. But that is such a difficult subject to tackle that I don't think that that's something I would feel comfortable saying that we can do for sure. As far as the other portions of this, I knew this question was probably sent before. Is yeah, we don't generate a MOS score. It's all match scoring. Now, as far as some of those parameters, you could probably tell based off of you could tell based a little bit off the match score, but I think what you'd need in a lot of those instances is something like a MOS score. So once again, we could tell you sort of how good it is, how good the audio matches comparatively. So once you add some sort of noise suppression or echo cancellation, we can say the match score improved by this much after you implemented that. But as far as more of a general score about those sort of parameters, it'd be difficult for us to tell you that.
Okay, thank you for that question, Tanaya. We have another question that came in from Nicholas. So the question is, could you explain at a high level how Bluetooth audio is configured and what Bluetooth devices are being used?
Yeah, so at a high level, the Bluetooth devices are sitting in the P box that Nadav showed earlier. They're connected, as I said, via Bluetooth to the device, and then they're connected to our host machine that has all the hosts on them. The Bluetooth devices being used is somewhat proprietary, so we can't go into that itself. But then what it does is it'll allow the host to hear. In this example, it'll allow the host to get the audio off for this performance session, but it'll also allow the host to then go put the audio back to the browser for us to hear live as well. And so, sort of at a high level, it's sitting in the P box and it's connected per device, and then connected to the host, so we can hear and listen both in the performance sessions and live.
Okay, thank you for that question, Nicholas. The next question that we have from an anonymous attendee is that for the web conferencing application, is there a way to inject or test a video stream as well as the audio?
Yeah, so I think it's very similar, for audio wise, we can test the audio, but you're talking about similar to the audio. And so in that case I had a webinar couple months ago where we talked about the AV box solution that Nadav mentioned during the demo. And with that, there's an ability to inject video streams into that can be then sent over the Zoom application or whatever the web conferencing application is of your choice. And then you could see that on both ends that the the video is being injected into that device through the AV box scenario. And as I said, if there's more interest of that, we definitely should check out that webinar, or we can have a conversation if that's something of interest in your applications. But it's something that we could handle.
Okay, thank you for that question. And the last question that I see here is, can we do, and there's one more that just came in, can we test multiplexing or multicasting with this product or platform?
So multicasting, I could see couple different definitions of. If you mean as in that, like connecting to multiple peers, that's definitely available within the platform. If you mean multicasting as in casting to different devices, I don't know how easily that could be done, but we can have a follow-up conversation about, what sort of use case you're working on, and then we could sort of solution how we'd be able to do that, or if we would be able to do that. As far as multiplexing, we actually have a third party we sometimes work with on special use cases, but it's not something that comes out of the product out of box.
Okay, thank you for that question. The last question I see here at the moment is from Arun. So can we measure audio latency round trip?
It would be an interesting solution. I think that it's something that we could, but I think that it would take some interesting scripting to do. I think there'd be a lot of things that we need to kind of figure out in that specific use case. So what in the phone call scenario, right? So you could talk about when the audio was injected from the phone, so you have that timestamp, and then when the audio was first received on the other device, and you could have that timestamp, and then compare those sort of timestamps. So that's one way that that's probably the easiest way I could think to do that. But if there's a specific use case, as I've mentioned a few times, I think that there'd be something we could follow up with. But that's probably the easiest way to do that from this demo. But there's a lot of different applications, and so I think it just depends on what sort of application in the requirements and how you'd want to handle that.
Okay, thank you for that question, Arun. I'll give it another minute to see if any other questions trickle in. And if not, we'll look to close out the session. Okay, well, it looks like there are no other questions at the moment. So just wanted to thank everybody for once again making the time. Oh, wait, we do have one more, just kidding. So Tanaya has another question for us. So how can I access the other session with the more in-depth performance analysis?
Yeah, so in the HeadSpin website, we have resources, and then we also have blogs, but for the webinars and events, we have a repository of the ones that are on demand. And the one that I'm thinking of right now is this one by my colleague Jamie, and this is where he talks about kind of an introduction on the performance KPIs that we have out of the platform right here. And just to kind of go over that again, so you go to the HeadSpin website, resources, and then webinars and events. And the first ones will be the ones that are upcoming, and then there'll be the on-demand ones down below.
All right, thank you for that question, Tanaya. Doesn't look like any other questions trickled in, so we'll look to close out the session here. Once again, thank you to everybody for making the time here to join us and learn a little bit more about how we address testing for these real-time communication situations. We hope that you found the session to be helpful and informative. If you have any questions that come to mind after this session, or are interested in scheduling a deeper dive conversation and demo that is tailored to the use cases and KPIs that matter to your organization, feel free to reach out to me directly at the following email address. I've also pasted it into the chat for the webinar. And please be on the lookout for other webinars in our series that we'll be running on a monthly basis to talk about a variety of different use cases and that are you can address with our platform, as well as kind of giving you as users a deeper understanding of how to leverage the platform day in the life on your end of the spectrum. We hope you have a great rest of the week, and thanks again for joining. Goodbye, everybody.